In today's lesson, 10.6, More Angle Arc Theorems, we'll be talking about some theorems that have to do with the arcs, and then we'll look at a few practice problems. The first theorem, Theorem 89, is actually something that we've seen in previous lessons. It basically says that if two inscribed angles or tangent chord angles intercept the same arc, they are congruent. We saw this in previous lessons with inscribed angles. So if we take a look at this, you'll see this angle right here and this angle, they share this common arc out here. And since they share that common arc, that will tell you that those two are congruent. The same can be said if we look at the other angle of this, going to the other side of the circle. They share that same arc, so then this angle would be congruent to that angle. The same can be said if we have tangent chord angles. In a previous lesson, we talked about how tangent chord angle is also half of the arc, as is an inscribed angle. So if I have an angle right here from the inscribed and the tangent chord angle shares that same arc, as you can see right there, then the inscribed angle would be congruent to the tangent chord angle. The next theorem we'll see is if we have two inscribed angles or tangent chord angles intercept congruent arcs, then they are congruent. So if we know that the arcs are congruent, that automatically implies that the inscribed angles would be congruent. And this should make sense because if this was 60 and we know that it's congruent and that's 60, and we know that inscribed angles are half, this would have to be 30 and this would have to be 30, therefore making them congruent. The third theorem we'll see tonight is an angle in a semicircle is a right angle. And this should make a lot of sense because if we have a semicircle, we know that a semicircle is 180 degrees. And if we take half of that, because it's an inscribed angle, that would have to be 90 degrees. The last theorem we'll look at tonight is Theorem 92, which says the sum of the measures of a tangent-tangent angle and its minor is 180 degrees. And the reason for this is because if we think of kind of through previous lessons of what we know that a tangent angle to the radius creates perpendicular angles. So this would be 90 degrees and 90 degrees. And we also can go way back and remember that in a quadrilateral, the sum of the interior angles will be 360. So if we subtract the other two angles, that gives us 180 degrees for the measurement of angle A and the measurement of angle C. And what you know about angle A is that it's the exact same as arc BD. So we can do a simple substitution and say that the measure of BD plus the measurement of angle C equals 180 degrees. And finally, we'll look at a couple quick examples. The first one that we have is, what is the length of a chord that cuts off an arc of 60 degrees in a circle with a radius of 5? Knowing that the arc is 60 degrees tells us that this angle in here is 30 degrees. Now, if we connect the line from the arcs to make a triangle, we'll also know that this angle in here has to be a right angle because it cuts off, or it creates the diameter here and here, which is 180, so that has to be right angle. From there, we know that the radius is 5, therefore the diameter has to be 10. And because this is a right angle right here, and this is 30 degrees, this has to be 60. So this is a 30, 60, 90. And if we remember the proportions of 30, 60, 90, or the ratios, the hypotenuse is 2x, therefore x has to be 5, which is across from the 30 degrees. So the length of the chord would be 5. And finally, our last example. Given the following diagram, and given that PT and QT are tangent lines, and the arc measurement of WZ is 126, and the arc measure of XY is 40 degrees, we want to find out what PQ is. So let's go ahead and label some things in our diagram. We know that WZ right here is 126 degrees. We know that XY is 40 degrees. And again, what we're trying to do is we're trying to find PQ over here. Now, the first thing we can do is we can actually go ahead and find the angle of this right here, of angle XTY. And we can find this based on, from our previous lesson, we can find angle XTY. And we do that by taking the 126 minus 40 divided by 2. And that will give us 43 degrees. So this measurement of this angle is 43 degrees. And since that angle and angle PTW are vertical angles, that means that they're congruent. So this angle will also be 43 degrees. And based on one of the theorems we just learned, we know that the arc measure of PQ plus the measurement of angle PTQ has to equal 180 degrees. So then we can do a substitution for 43 degrees in here. And that will figure out for us what PQ will be, which is 137 degrees.